Okay, hello everyone, welcome to this TouchDesigner tutorial. Today we're looking at this creating this particle system with a tiny bit of GLSL. So let's jump right into it and jump up a level and delete this project 1. So I like to create use base when I start projects because usually I do not need UI components at this level. So let me just rename this to PS particle system, and just before we start we're going to create our render setup right away, and even before that let's customize our components so we can store a couple variables. So first in the page settings, we're going to add a page settings. Here we go. So here we have it, and a couple things I want to create. I want to have a resolution that I'll be able to modify as I go, and a simulation which will be my particle system, which I'll call sim also for XY. So here we have it, res X, res Y, sim X, sim Y. Beautiful. I'm gonna add a float, which I'll call aspect. And finally, I'll call in a speed to drive the speed of our particle systems. So I know that my speed is going to be from 0 to 1 is going to be too quick. So let me just have the range maximum from 0 to 0.1 here. So now I go from 0 to 0.1. Beautiful. Speed really doesn't is not in the same category of those 3 other variables. So just let's add a section to it. So we just create this little line. Beautiful. So in the resolution, let's stay in the default resolution of the non-commercial version of TouchDesigner, 1080 by 720. And in the simulation, let's take 10 by 10, so 100 particles. For our aspect ratio, let's bring in our resolution in here. Let's reference it. So me.par.resx, let's copy paste it. So and let's replace the x by a y. So now we have me.resx divided by me.resy, which will always give us our aspect ratio. We don't need to modify this ever again, so let's just toggle the read only. Okay, that's it for now. Okay, this is our variables. We will use them a bit later. They'll be super handy right here. We'll call them back at some point. Let's create our render setup. So most of you probably know about how to create a render setup. So let's just do that. So first I want to bring in a circle sup, which will be my particle. And as seen as in the example, I don't want a round particle. I want to have a triangle or anything facing forward. In this particular example, we're going to face forward, like Z is going to be forward for our particle like this. We're going to be able to orient it easily on the z-axis, but it doesn't really matter if you do it otherwise, if you make sure to orient the particle when we'll be there. So I want a triangle, as I said. So let's not have a 40 division, which is way too much and creates a pretty smooth circle, but only 3 divisions to have a triangle. So I can modify then the radius here, but I want to stay in procedural style, let's say. So I'm going to add a transform like this. I can always modify my particle upstream, and it won't affect the next modification I'll do. So I know that I just want to have the the scale y at 0.5 like this, to have a narrow particle, more like an arrow. Okay, and now let's connect this to a geometry. Okay, so while I do this and you guys follow around, I would tell you this this tutorial is more oriented to like beginner to intermediate level. If you're advanced, you probably will not learn something new until we jump in GLSL. If you don't know anything about it, there you might see a couple concepts you're unfamiliar with. Okay, so we have our render set up. this is good. Let's add a null and let's call it BG. Let's add a constant mat. Let's call it constant PS for particle system. Same thing for our geo PS for particle system. And let's drag this. Oh wait, yeah, let's drag this on the material, and we're just missing a camera. And here we have it. Beautiful. So I will never need again this constant. So I don't need to see it again. So I could put it inside my geo, or another thing I could do, I could dock it to any operator. In this case, I'll dock it to my geo. So it's still fully accessible like this, but I don't want to see it anymore. This is good. Let's put the display active here. This is a bit big for me. It's a bit too much in my face, let's say. So let's make it smaller and drag it in the corner so we still can see what we're doing. And finally, let's bring down our uniform scale to 0.1, just so we have a smaller particle. We can adjust this later. Okay, superb. Next. Okay, next we want just to start our instancing setup. So let's bring in a noise like this, and let's put it in the right resolution. We'll do also the same thing for the render, which we have not done yet. So on my parent, which you can see on top here, right click, parameter, it appears here. So I'll start with the render. Let me just drag my resolution onto my resolution of my render, and let's bind those two values, because if one changes, it makes sense that the other changes also, and it's not going to be dynamic changes, so it's okay to stay in a bind like this. And same thing for my simulations, and we bind it like this. Cool. Okay, so let's focus on our tops for now. So first of all, I want it to be a nearest pixel and 32 bits. I want to add a null, which I will call position. And I want my noise to be in RGB, so not monochrome, so toggle off monochrome, and 0 centered. And let's have an amplitude of 1. Okay. So all this is probably known by you right now. Let's go to the instancing page, toggle on instancing, and our texture pause will be our default instant operator. So let's use our G and B. So all this is good. I do admit I do not want any depth, so I did put on the B component here. So if we look at the geometry, we see we have depth here. This is non-desired, so with a math, I'll just cancel out the B. I do not need it or want it for now, because we will stay in 2 dimensions. Okay. So now that we have this, let's animate a bit our noise. For this, so we have created a speed parameter here. Let's use this to drive our noise. So I'm going to bring in a parameter chop. Okay. Here are all my customizable, not customizable, yeah, all my custom parameters. So let me only select the speed, and this I will plug it into a speed chop. And with Alt N, I will add a null and call this one null speed. So I do not need Simplex 3D. I can only use Simplex 2D. This is fine by me. And bring this in my translate Y. Okay, and with my parameters here, I can bring this to go a little faster like this. Okay, here we can see that we're not really going to the edges on the y-axis of the Canva, but we are going to the height, the x-axis. We're not going. We're going to the y-axis, but not to the x-axis. This is because and we're going a bit further, and which is okay. Let's look at it in here. Yeah, so we're overshooting a bit over the y-axis up to 1 and under -1, and we're doing the same for the x-axis, but I want to go a bit further on the x-axis. So to do that, well, we're going to use our aspect ratio, because we want to fill our canvas. We want to have the feeling that the particles are floating everywhere. So in our math, so here we cancel. Let's write it here. So we did cancel B, and let's write aspect also. I don't know if this is helpful, but at least we know some of those things are happening in here. Yeah, not cancel, but cancel. Okay, so my aspect ratio, even though it's read only, I can still take it and drag it on the red value, which is the X value. So I want my noise not to be squared, but have like a multiplying factor on the X factor. So so you can see that it's moving more in like a rectangular fashion, and it'll be more fitting in our screen space, which is in an aspect ratio of 1.7. Okay. All this is now good. Now let's jump into a little GLSL. Okay, so now we need two things. First, we want to orient our particle. So we want the pointy part of our triangle to be oriented in the direction of the motion. To this, we're gonna need to find the direction of our particle, so in which direction it's going, and then we want to color the particle in relationship with its speed, with its velocity. So to find the velocity and the direction, which are kind of similar or like the same thing at this point, we need our actual position and our previous position. From there, we'll be able to find our the angle between those two different states and the length of this new vector we've calculated. So let's bring in a GLSL. Okay, and let's put a null here, and let's call this one. This is going to be our null position. This. Okay, Control E to open in your script editor the GLSL script. Let's do it like this. Okay, so if you're really new to GLSL, let me break this down real quickly. So let's uncommon. This is what we want. So our color is coming in from a texture, which is plugged into the top here at index 0. That's pretty much what we need for us right now. We don't need it to be called a color, so let's call this position. Okay, now we need our previous position. So like one frame ago, where was our particle? And this will enable us to do the calculations needed. So let's bring in a feedback just after our null pause and before our GLSL. Let's add a null here. Let's call it null feedback. And this will be sent into the feedback. So this is the feedback here will be our previous position. It's just the position of one frame ago. Okay, our GLSL is being updated every frame, and one frame ago so is our previous position. So now I can just copy this line back in my script and call this one previous, and we want the texture of the input at the indexed 1. Okay, so far so good. Next, we have two things that we really want to find. We want to find the angle between those two positions, so the previous position and the actual position, and we want to find, we'll call it the velocity. So what distance it has traveled, and at what speed it has traveled also. We can see it in this way. So first, we even need to, before we calculate all this, we have to calculate our direction. Direction is really easy to find because we have a previous and actual position. So to calculate the direction, you have to take your actual position minus your previous position. And here we get an error. So why is this? It's because direction is a vector of 2 dimension, xy, and pos and prev are 4-dimension vectors. So let's just invoke it as a 2-dimension vector, r and g, because that's the actual values that we're interested in. And now all of this is good. Let me just take this and put it in nearest pixel. Okay. So we have our direction. Velocity from there is very easy to calculate because we just need to find the length of that direction, of direction. And this is equal to velocity, as simple as this. Angle is a bit trickier just because you have to remember a bit of trigonometry. So you can go check that out. It's fairly simple how to find the angle of a vector. So translate from polar coordinates to an angle. We're gonna use atan. And atan wants two values. It wants the y value of our triangle, of our vector, and the x value. So direction y and direction x. Oops, like this. Okay, no errors. This is good, but TouchDesigner is expecting degrees and not radians, as atan is going to give you the value of the angle in radians. So let's encapsulate all this in parentheses and invoke the degree function, which is native to GLSL. Beautiful. So we have everything we need. What we want to drive our particles is the position, their actual position, their velocity, and their angle. So let's encapsulate all this in. We could in a new vector. We don't have to do this. I just want to explain this example. So a vector in GLSL, you can see a vector or any vectors also, like in container. So it's a vec4, and you have like 4 slots in that variable. You can store 4 things in it. So this will obviously not work. So what I want to have here is pose R, pose G, RG, so RG, our position, right? And our velocity and our angle, which are floats, right? So let's put our velocity here, and here our angle. So that's a way to do it, and also you don't have to write pose R por G. You can just write it like this. GLSL will understand that this has 2 values, that it's a vec2, a float, and all those together will make a vec4. Let's not call this container, which it kind of makes no sense. Let's call it color out for some reason. Okay, and let's bring this and replace it in the TD output swizzle. So everything is almost done right now. GLSL is done. We've got all the values in one texture to orient our particles. So the very satisfying one is the orientation. So where did we put it? We put it, our orientation, our angle, in the A component of our output here. So let's rotate on A. So now we see super easily that now our particles are orienting themselves in relationship with their movement. Great. And now I want to color them on how fast they're going, okay? Like a kind of a visualization of their speed. So I'm gonna take a reorder because I want to create a black and white texture so I can use a lookup right after. And we said that our velocity was what it was in the B component, the blue component of this texture. So let's put everything in blue and the alpha to 1. And then, oh, it's all black. Is this normal? Yes, it is. So you can click on the viewer active to inspect your pixel, your texture, and then click on D, and then you see the values of each pixels by selecting them. So this is a super useful way to do things. So we see that we have values, but they're just very small. So let's add a math, and we're gonna call this one a scalar. And let's, by doing it a bit earlier, I know like in the 80, maybe a little less. I want something that is, yeah, that sounds good. 70, just multiplying it by 70. So I have a black and white texture. I'm gonna put a lookup, add a Alt N to add color, add a null, Alt N to add a null, color, and a ramp here that I will plug into the lookup, select all this, and nearest pixels, and now let's just create little colors. So something like this, but a bit more like pastel. So let's bring our color into our instancing page number 2. Let's just drag it here, and let's put our G and B. So the faster they're going, the reddish they are. So all this can be art directed very easily. That's why we made the effort of bringing everything back in black and white. So not totally confident with my color selection, but I don't want to spend too much time doing this. So let's just keep it like that. Okay, so this is the end of what I really wanted to show you. So you can see that we have our parameters here. We can up the size of our particles pretty easily, but it kind of defeats the purpose if you can't see them. And we can make them go faster or slower, which will obviously impact the color. So this I like. And then I just want to do a little post effects on my little creation here. So you can stay with me while I do this. So since 2023, we got this beautiful new top, which is Bloom, which really does a little magic, I find, and give a little oomph to your visuals. So let's take this and then let's, is this a little strong? Maybe tiny little strong, too strong for me. Then let's do something which is very classical of TouchDesigner. Let's create a feedback loop to have this this kind of little trail effect. So let's put in a level. Let's put our level at 0.945, which is my magic number for feedback. Let's put a little blur. Let's bring in an over. Okay, and our bloom is going to be piped into the over here, and our over, this is kind of confusing. Our over, let's send it on the feedback. Okay, so this is obviously very strong, and that's it. That is not the effect desired. So let's not use the bloom. Let's use the feedback, the render, and let's add a null. So the whole network is clear, yeah, like this. So let's just only look at our trails right now. Let's deactivate the blur, see if we really need it. Is this good? No, not yet. And maybe we have too much blur. We just want a little blur. Oop. Okay, and then All right, let's put our bloom over the whole shebang. Yes, this is kind of, this is a little more what I'm looking for. Not totally convinced yet, but I don't really mind, because that was not the goal of this tutorial. I'm gonna add a constant. I'll even call it constant BG. Okay, let's put the color under and not multiplied, and I want kind of a little gray. Yeah, not loving it. For some reason, I'm not loving it. Let's pump up this a bit. Maybe it's going a little fast also. Let's bring down the speed. And crank this up once again. Well, you know, sure, why not? So from here, it's pretty much over. Let me show you a couple tricks I do to keep my network the tightest as I can. So all this, which are post effects, we can just collapse select, and let's call this the post effects. Okay. Oh, look at this. We have like those artifacts of trails here. Yeah, that is not desired at all. So here, can you see it? Maybe, I don't know if you can see it, but like we have a difference where the feedback has passed on. So there's a couple of tricks to do it. One thing I really find useful is just to transform that little part in. So use a transform. Let's get rid of the null now, and bring the whole thing in 32 bits. And you see this whole thing has totally disappeared. Okay, so let's call the render main. Our geometry has no need to be exposed anymore, so let's cut it, bring it in the geo, delete everything, put it back in, add a null. I like to call it null R, activate display and render flag. And here we have it. This is a pretty tight network. Not anything too complex, but still we're getting nice variations on our particles, and we're getting orientation. We could play on the speed, on the scale also, so a particle could be bigger or smaller depending on the speed. So if you liked it, please leave a comment or like the video and all that jazz. If you do something from this tutorial, please share it with me on Instagram, and I'll be happy to repost it. So until next time, hope you have fun doing some TouchDesigner, and see you soon.